Today we will discuss the chapter Structure of Atom or Atomic Structure. Class 11 standard. All of you know that Dalton has given the atomic model. Then it was developed when the Thomson discovered the electrons. J.J. Thomson giving the plum-pudding model. All of you know that atom is a positively charged sphere and electrons are embedded on the negatively charged electron, which is negatively charged embedded on the positively charged spheres, called the plum-pudding model. Then it is the Rutherford. He is giving the model, atomic model, after the experiment by the Goldfield. That's called a famous experiment, Rutherford's Goldfield experiment by the alpha particles. He is giving the atomic model. And then it is the Bohr who has developed the atomic models, and he is giving the atomic models based on the radiation and according to the classical law of physics. So today we will discuss about the Bohr's model, and then we will try to calculate the radius of the hydrogen atom or hydrogen-like atom, velocity also, and also energy. Now first, the Bohr's model. Bohr basically accepted the Rutherford atomic model, and he is giving the following models for the Bohr's model. So first, you see, already I have told this one. You see that today topic atomic structures, subtopic is Bohr's model of hydrogens. Point of discussions, introductions I have already given. Postulates of Bohr's theory, I just start. Now, so this is the postulates of Bohr's theory. An electron revolves in a definite circular path around the nucleus called orbit or shell, which is denoted by N. So this is the first postulates of the Bohr theory. Okay, here we get the idea of the orbit or the shell. Here we get the idea of the, once again I am telling, orbit or shell, in which the electron revolves. In which electron revolves. In which electron revolves. Then, second postulate, electrons are allowed to the orbit in which angular momentum is quantized by h by 2 pi. That is, angular momentum MVR is the integral material of h by 2 pi. That is, MVR is equal to NH by 2 pi. Where N is the number of orbit 1, 2, 3, M is the mass of electron, B is the velocity of electron, and R is the radius of the atom. H is the Planck's constant, which is 6.626 or some book written 6.625 into 10 to the power minus 27 arc second. If it is in SI process, then 6.625 into 10 to the power minus 34 joule second. Pi is equal to 22 by 7 or 3.14. Here, one thing I want to let you know. What is the angular momentum? Angular momentum is in terms of linear velocity when I am writing in here. So can you tell me why angular momentum is coming in here? We know the angular momentum, so let us say particles moving in a circular path. We know angular momentum, actual definition, angular momentum, actual definition I, moment of inertia into omega. What is omega? Omega is the, when a velocity revolves in a circular path, the circular velocity. Let's say an atom we are considering Here it is the nucleus. When electrons say when it is revolving in the circular path, so this is the linear velocity and this is the angular velocity. R is the radius. So this is right angle because linear velocity along the tangent. That you know the relation between the V and omega. V is equal to omega into R implies omega is equal to V by R. So momentum inertia I is equal to a1 square and omega is equal to V by R. So therefore you can write R cancel out, you know, so that is the A V R. So now we can write the angular momentum when we write in terms of linear velocity that comes in here. This question is to come exponent y angular momentum y is ampere. So then we can write, so this is the angular momentum is equal to ampere. Second postulate is okay. From here the question given in the last I will try to give one questions. Then the question number postulate number 3. Then the postulate number 3. The electron is in orbit in stationary state. Stationary state does not mean that it is the electron is fixed. Stationary state means that the energy of that electron in that orbit is fixed. When an electron jumps from one orbit to another orbit, energy is either negated or absorbed. According to the Planck's equations. Planck's equation is equal to h2. Whichever energy is greater from the energy will E2 minus 1. That whichever is greater from subtraction express accordingly is equal to h2. And h nu is equal to frequency or nu is equal to c by lambda. And h is the Planck's constant, that already h is the Planck's constant, and c is the velocity of light, and lambda is the wavelength. Lambda is the wavelength. Now from here also numerical comes. Okay, E is equal to h nu. In better way you can write E is equal to n h nu, or n is the number of proton, h nu is equal to c by lambda. From here also we can calculate the numericals. You can do the numericals. Okay, n is the number of proton. It is the number of proton. Now you see next part. Our objective is to calculate the radius, velocity and energy of hydrogen-like atom. So how will calculate the energy, radius and velocity? Now let us consider a hydrogen-like atom. We know the Bohr orbit. Bohr is applicable for the hydrogen-like atom. It is not applicable for the multi-electron system. Okay. So let us consider. So our objective now calculation of radius Rn, velocity Vn, and energy of En of hydrogen-like atom. Of hydrogen-like atom. So let us consider a hydrogen-like atom in which you see an electron revolving. Its velocity, linear velocity along the tangent. Omega is the angular velocity, and it has one inward force, that is the F1, because positively charged nucleus and electron negatively charged attacking, and that is also outer force, that is the centrifugal force. F2 is the centrifugal force. F1 force. Attractive force. When considering the mass of electron A, charge, the magnitude of the charge of electron E, Coulombic attractive force, you know the law, is equal to Z Q1 into Q2. K is the permeability constant, Q1 into Q2. If the two charges are there and distance R square or D square. Now, okay, here K into E square by R square distance. K is the permeability constants. K is the permeability constant 1 by 4 pi epsilon. For each CBSE system, this is equal to 1 we are considering in CBSE system. And when the air is the permeability, air is the medium, and in CBSE system, this value is 1. So we are considering this K is equal to 1. And centrifugal force is equal to what? That we know, that is equal to mv square by R. What is it? A is the mass of electron. Mass of electron. We are considering. And E is the magnitude of the electron. We are not considering the negative signs. Magnitude of electron. Z is the atomic number. Z is the, you know the atomic number that you know. So, when the electron revolving around the nucleus, as well as revolving, Coulombic attractive force and centrifugal force are equal to each other. Therefore, we can write Coulombic attractive force, that is the, and I am writing F2 right left hand side and F1. That means we can write mv square by R is equal to Z E square by R square. Okay, Z is the charge. Okay, now Z is equal to 1 for hydrogen atom, Z is equal to 2 for helium ion. Okay, now we can write mv square is equal to Z into E square by R. So this is equation number 1. Equation number 1. Very important part. mv square is equal to Z E square by R. Then after that, Bohr's second postulate, that is the mv is equal to NH by 2 pi. This is the second postulate we have learned. Second postulate we have learned mv is equal to NH by 2 pi. Now you see here we can write shortly from second postulate. Second postulate of Bohr's model. Niels Bohr. Bohr's model. We can write this one. Therefore, B is equal to NH by 2 pi m/. B is equal to 2 pi m/. Simply B is equal to what? 2 pi NH by m/. So equation number 2. This is also very important equations. Now left hand side mv square. Now we have to take in terms of, if you want to equalize, first you have to square this one, then you have to multiply by m, then we can, left hand side will be equalized. Then right hand side you can write that they are equals. Now from equation 2, first we will square, then multiply by m. So I am writing directly. Therefore you can write mv square. mv square left hand side. Okay. Then is equal to what? N square h square by equal 4 pi square squaring m square I will write n because already you are multiplying by n, that will cancel out. That's why I am writing this one. Okay. So this mv square, now it becomes mv square, like say 1 left hand side mv square. Now you can write this is equal to Z E square by R, is equal to Z E square by R. Because from equation 1, we have written this one. From equation 1. From equation 1. Now we can write from these equations R and R cancel out R. Now we can write directly R is equal to what? N square H square by 4 pi square E square M into Z. I hope it is the expression, it is clear. It is the Rn, it is the expression for the radius, which is our objective to find out radius. So this is the expression for radius R for hydrogen-like atom, where R is equal to what? N square H square by 4 pi square E square M into Z. N square and by Z is there. Now you see, we can write this one, putting the value of H, Planck's equation, pi 3.14, 3.14, magnitude of the electrons and mass, we get 0.529 into N square by Z. So this in angstrom unit. So this is very, very important. This is the radius of the atom, where N is the number of orbit, okay, and Z is the atomic number. For hydrogen, Z is equal to 1. For lithium, Z is equal to 3. Helium, Z is equal to 2. Like that. So it is applicable for in-electron system, not for multi-electron system. Helium ion, He plus ion, or lithium, Li2 plus ion. In its 3 electrons are there, 2 are lost. That means 1 electron remains. So we have done the radius calculations. Now our objective to calculate the velocity. How you calculate the velocity? This v is equal to nh by 2 pi mr. Here r is there. In this r, put this value of r. So in equation 2, so this is little bit equation number 3. Putting the value of r in equation number 2, we will get the velocity. That means velocity of the electrons. Now I am going next phase. V is equal to, we know V is equal to nh by equation 2 is what? Equation 2 is V is equal to nh by 2 pi mr, 2 pi mr. Now already we know R is equal to what? R is equal to this. R is equal to what? N square H square by 4 pi square E square M into Z. This is from equation number, you see equation number N square H square 4 pi square E square M Z. Equation number 3. Equation number 3. Equation 3, we can get this value of R. Now putting this value of R over here, this is the NH by 2 pi M into N square H square by 4 pi square E square M into Z. Now we can write V is equal to, you see the NH cancel out, okay, 2 pi M will cancel out. Now you can write this is the 2 pi E square by NH 2 pi A square Z is there. So this is the equation for the velocity. Okay, equation number 4. So velocity expression we got the velocity expression. But we know Z and N, it is variable. Okay, therefore putting the value of pi E and H, we can get velocity is equal to 2.19, some book is right, is written 2.18 into 10 to the power 8 into Z by N in centimeter per second. So this is the velocity of the electron in general. If the Z is equal to 1 for hydrogen atom and N is equal to 1, that is the value 2.18 into 10 to the power 8 centimeter per second. But if the value is for helium ion and Z is equal to 2, then 2 by 2, same. But in the lithium ion, so Z is equal to 3 and N is equal to first orbit into 3. It will be into 3. So we can do lots of numerical from this velocity. Okay. Now our objective to calculate the energy of the electron. We know the energy of the electron when the electron revolves in a circular path. Total energy is the kinetic energy plus potential energy. So total energy we can write E is equal to kinetic energy plus potential energy. So kinetic energy is equal to half into mv square and potential energy is equal to minus Z square by R. How potential energy is coming minus Z square by R? We know the potential energy is equal to when we bring an electron from infinite distance to that orbit, okay, the energy infinite distance to that orbit and Z square by R square here. So this is actually potential energy how to calculate. When we bring an electron from infinite distance to that orbit, the amount of energy required, that is the potential energy. Mathematically, we can calculate by doing the integrations infinity to R, and that will be the minus Z square by R. So that's why the potential energy is minus Z square by R. So if you have not done the integration and calculation at the beginning, so we learn integration later on. For the time being, we can remember the potential is equal to Z square by R. Now, mv square I have told you that mv square is equal to first equation. We know that mv square is equal to what? Z square by R. So putting that value, mv is equal to half into Z square by R minus Z square by R. Okay. So we will get this one, that is the minus 2. This is 2 what? Minus Z square by R. Minus 2R will be below, and that is the minus Z square by. Now once again, by putting the value of R, we can get the total energy. So what is the value of R? R we have already done. Should I write? Okay, let me take another page. Okay, now R is equal to, R we have already calculated. R is equal to N square H square by 4 pi square A square M into Z. This is from equation number 3. From equation 3 already we have got this data, and then total energy we have calculated just now. This is equal to what? Minus Z square by R. So now E is equal to minus Z square by R. Now we are putting the value of R. Here is a 2R. Sorry, this is a 2R. Z square by 2R. Z square by 2R. Okay. Now minus Z square by 2 into R is equal to N square H square by 4 pi square E square M into Z. Now 2 to cancel out. Okay. And then you can write minus 2 pi square e to the power 4 M into Z square by N square H square. So this is the energy of the electron in general. Okay. Now we know the Z square and N square, this is the variable. Okay. Therefore, putting the value of others, we can get minus 13.6 into Z square by N square into electron volt per atom in the unit. If we write in kilocalorie, minus 313.6 into Z square by N square kilocalorie per moles. And if it is in the kilojoule, that is minus 1312 into Z square by N square into kilojoule per mole. So lots of numerical we can calculate Okay, based on this formula. If the unit is giving kilocalorie, we use this formula. If it is giving the electron volt per atom, we use this formula. If the electron is giving unit is giving kilojoule per mole, we will use this formula. So we have calculated the energy calculations and this velocity calculations, and we have done the radius calculation. We have done the radius calculation also. Okay, radius calculation is this. Okay, radius. So all this calculation we have done. Okay, radius, velocity, and here one thing you just keep in mind. Now I am giving one question to you. Why the negative signs comes in the energy calculations? Okay, so this negative, why the energy is negative? Can you tell me? So this is the questions, and I am giving you the questions. I will ask in the next class why the energy is negative. Okay, for the time being I am going for the some numerical questions. Okay, now question is given according to the Bohr's theory, the angular momentum of an electron in the fifth Bohr orbit is. So very simple. Okay, this question came in the NEET. Okay, but it's very simple. Angular is equal to N by 2 pi. So here it is giving the fifth Bohr orbit. N is equal to 5 by 2, A is by pi. So this 5 by 2 means 2.5. 2.5 into A is by 5. Which one is correct? So option number D is correct. Option number D is correct. So this is the correct. So this question came in the NEET but very simple. So that this question is to come. Then another question I am giving, Bohr's model. Can explain these theoretical questions. Bohr's model can explain the spectrum of hydrogen atom only. The spectrum of atom or ions containing one electron only. The spectrum of hydrogen molecules. The solar spectrum. Which is correct? Can you tell me which is the most appropriate? Sometimes you find all the four options are correct. Out of the four, which is the most appropriate? That is the answer. Okay. Now here most appropriate is option number B. Option number B. Okay, this is the correct answer. Now the last two questions of today's sessions is very important. Although the question is not the Bohr's, it is based on the Rutherford's experiment. All of you know the Rutherford experiment. We have done the Rutherford's model. But whether it has the numerical or not, most of the students they don't know. It has also some formula to get the numerical, to do the numericals. So that two formula used over here. One formula numericals are giving. Okay. So in the Rutherford experiment, scattering experiment, the number of alpha particles scattered at an angle theta is equal to 60 is 12 per minute. Question is the number of alpha particles per minute when scattered at an angle 90 degree. What should be the answer? What should be the answer? Which formula we will use? Do you know the formula? We see most of the students they don't know whether it has any formula or not. Number of alpha particles scattered at an angle, number of alpha particles scattered at an angle theta, that is the in theta, two formulas there. That formula I am giving. One formula is proportional to Z square. When question is to come, when there is gold foil is replaced by other foil, they use this formula. When the foil is changed, another formula is number of alpha particles scattered at an angle theta. When angle is changed, in theta inversely proportional to the sine to the power 4 theta by 2. So this is the questions. This is the formula we use over here. We use over here. Now, what should be the answer then? Now, L theta 60 by L 60 by L 90. Okay, inversely proportional. Okay, then L 60 will be what? This will be the sine to the power 60 by 2. Or L 90 is equal to what? Sine to the power sine 90 by 2, that is 745. 4. Because it is the power is 4. It will be the whole 4. That means it is a sine 45 and sine 30. Whole to the power 4. Sine 45 1 by root 2. 1 by root 2 and sine 30 half. Sine 30 half. So it will be like this, sine 30 half. Okay. Now root 2. Okay. That means it will be the 4. Root 2 to the power 4, to the power half into 4, that creates that is the 4. Now here N60 is equal to what? 12. Now N60 is equal to 12. Therefore you can write this side also. Since N60 is equal to 12, therefore 12. What I am writing over here, better you can see. N60 is equal to 12 by N90. N90 is equal to 4. So N90 is equal to 4, 3. Therefore N90 is equal to 3. Number of alpha particle, okay, per minute when scattered at an angle 90 is 3. That is the option number 3 is correct. I hope it is clear. So two formula may come. One is in the Rutherford experiment. That also most of the students we don't know. If you know is okay. If you don't know, please mind this formula. When the coils are changed, we use this formula. When the angles are changed, we use this formula. I hope it is clear. Thank you, dear students. Again, next class we will discuss. Thank you all.